Okay, so what do we have? We have Alex J and Andreas B. And the reason that we're showing you this is because they came up with some very creative ways to get to 10 from just 4 4s, and Andreas's situation 4 6s using factorials. Now, I was really, really excited about this, and I'm more excited by all of you attempting. Now, Hannah came up with something really, really cool. And Hannah, can you explain to the group the word and the concept that you came up with, please? And I'm gonna put everybody's hand down now in one shot. I think I can do that by just hitting lower all hands. There we go. And Hannah, I am looking for you to explain your process. Go for it.
I used concatenation to find 10 with 4 numbers. And at first I only found them with, I think it was 3 and, or it was 7.
Well, I think with 7, you found 4, right? So 7, 7, 7, 7. Now, this concept, guys, was not allowed by the target number game, but Hannah was using her creativity and said, hey, if we can put the numbers 7 and 7 together to make what?
77.
77, and we divided it by 7, what would we always have to get?
11.
And 11 minus 7 gave us 4. Now, what I was really excited about is, doesn't this work for every number?
This
So it's
77 divided by
77 minus 7.
So how about 88 divided by 8, which is 11, minus 8, and that's 3. And so that continues on forever. And Hannah, I just think that that's incredibly creative, and I love it. And Luca, you had a question?
Did anybody watch the space thing? The space shuttle that they just canceled because of the weather?
I know, I saw.
Yeah. It was so annoying.
Well, one of the mathletes actually explained to me in the last class that it was the weather that caused the delay, but they're going to do it on Saturday anyway.
Yep.
So I would highly recommend that you guys watch it. The other thing is that the guy that owns a company called Virgin Galactic, his name is Richard Branson. He's a very famous business person. I actually met him at one of his, he owns a lot of resorts, and I was in Morocco 2 years ago, and he was there, and guess what we talked about? We didn't talk about space. We didn't talk about airplanes. We talked about one of his favorite subjects and mine, kite surfing. So we talked about kite surfing, but we actually talked about the mathematics behind it. And this guy, he is a brilliant, brilliant mathematician. So it's so much fun to think about what people are capable of. Now, Luca, you have very good instinct, and I'll tell you why. Because today we are talking about deep space. Not only are we talking about deep space in the solar system, out of the solar system, but deep space within the atomic structure, everybody. We're gonna change the way you guys think about mathematics. And it's gonna start with a very simple concept. You guys know how powers of 10 work, yes? You guys know that if you do 10 to the 6th power, you have 10 times 10 times 10 times 10 times 10 times 10. 1,000 times 1,000 is 1,000,000. Can anybody tell me what is the major pattern that we see in the powers of 10. Who can describe for me the major pattern? And I'm looking for hands up here, the electronic hands up. And Adalia, go for it.
There's another 0 at the end of the number.
There's another 0 at the end of the number. That is a great, great start. Let's see. Why don't we go to Hannah A?
Well, they add on another place value each time you go up in a number.
Oh, I love the phrase place value. Absolutely love it. Ethan, what do you see?
Every single one's 10 times larger than the previous.
That is absolutely correct. Lila, what do you see?
You multiply the number before it times 10.
Exactly right. And Luca, what else can you share with us?
I was just saying the same thing as last time, basically.
Yeah. Now, guys, I want you all to notice this. By the way, somebody's got a clicking thing on their computer. If you can stop those notifications or mute yourself, then we don't have to hear the click, 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 click. Okay, here we go, guys. Watch this. Look at 10 to the 6th power, please. And do you notice how many zeros are in 1 million?
6.
6. Look at 10 to the 13th power. There are 13 zeros in 10 trillion. And so it's quite a beautiful thing. Oh, Alex, you were going to share too. And you're muted, so you can't be heard yet. There we go.
I have the same thing as you did.
Okay, great.
You can do a 1 higher power and then it corresponds to the amount of.
Yeah, guys, let's talk about the bigger numbers. 10 to the 6th is 1 million. And then when we keep adding 3 zeros, that means times 1,000, times 1,000, times 1,000, times 1,000. We go from 1 million to 1 billion to 1 trillion, all the way to duodecillion at 10 to the 39th. But at 10 to the 100th, we're at Google, and 10 to the Google, we're at Googleplex, and we're gonna learn next week. I have a lesson planned for you that's gonna deal with the incredible power of numbers like you've never seen before. And it actually, next week's lesson, I'm not gonna give it away, but it was inspired by Hannah and by Seth. So Hannah came up with a new rule for this game where you can put the two numbers together like 77. And Seth came up with his own concept of, what was it called, addenorials? Guess what? Seth, that's what a mathematician did back in the 1930s and changed the world of big numbers forever. So we're gonna learn about that in a little bit, and I'm really excited about it. Now, I want you guys to all go to page 4, please. Go to page 4 in your packet. Now, the first thing I want you to do is I want you to show me, please use the correct finger. This is, show me your forefinger. Now, take your forefinger sideways, and I want you to bend it and make a horizontal segment at the top of that knuckle. Everybody do it and point to it. Now, put your fingers on each knuckle, and that, my friends, is gonna be almost exactly 1 inch. It's also almost exactly 2.5 centimeters. Now, put your knuckle on the piece of paper that you printed. And if you printed it in actual size, you will see, is anybody way off from 1 inch? Now, you will, when you show this to your parents, if your mom or dad have larger hands than you, they're gonna say, oh, wait a minute, mine's 1.25 inches. Mine is 1.5 inches. So mine happens to be 1.25 inches. Some parents will have 1.5 inches knuckle, but most kids at your age, this is a great way to do an inch. Now, what I love about it is, don't we know the approximate conversion from an inch to centimeters? Who can give me the conversion? Raise your hand electronically, please. Lila, do you have it? Adalia?
Is it is it two
Yes.
and a half centimeters?
That's it, guys. The ratio is 1 inch to 2.5 centimeters. And guys, I want you guys to go down a little bit in the page. And can you write down your height, please, in inches? And if you don't know what your height is in inches, maybe you can write down, I don't know, what would be a good number to write down? For instance, my height in inches is 69 inches. Now, I believe that kite surfing is actually making me taller because it actually stretches you upward. So I am going to take a little liberty here, and I'm going to call myself 70 inches, which I'm not. I'd like to be, okay? Now, 70 inches, which is 5 feet, 10 inches, all I have to do is multiply 70 by 2.5. Now watch this, guys. Who can tell me what is half of 70? On 3. 1, 2, 3, go.
35.
Who can tell me what is double 70?
140.
140.
Smush them together, and what do you have?
175.
And that is almost a perfect connection. Now, if I were to go from there, everybody, and I were to go to meters, since there's 100 centimeters, cent is like 100 cents or a century. Since there are 100 centimeters in a meter, all I have to do is take my decimal and move it over 2 places, and I have 1.75 meters. Who can tell me their height in meters? Alex?
I'm 1.4.
1.4.
1.4. David, what about you?
I'm 1.5 meters.
And, keep going, keep going. How about you, Luca?
I don't know.
Oh, wait, no.
Okay.
Maybe something
Zarak, what about you, buddy?
1.397.
Whoa, that's awesome. That's really specific. I love specificity. Adelia?
1.6.
1.6. Wow, that's a good one. That's a good one. You know, you're catching up to me. Be careful. You could be my height if you do a little more kite surfing. How about you, Ben?
1.575.
1.575. So guys, I have some bad news for you. And the bad news is there are only 3 countries in the world that do not use
Metric system.
And what's really interesting about it, not all of you were with me then, but a few weeks back, we talked about latitude, longitude. Do you guys remember that very origin of our Earth, which is 0 degrees latitude, 0 degrees longitude?
Yeah.
That is very close to a country called Liberia. Liberia is in Western Africa. They use the standard customary system, otherwise known as the imperial system, okay? Who invented the imperial system? The British. The British invent it. The British send us, do some bad stuff. We take the United States or back from Britain. We adopt the imperial system, And then in the mid 1900s, Britain goes to metric. Everybody goes to metric except Liberia, the United States, and Myanmar. Now, Myanmar, guys, is in Southeast Asia near Burma, Bangladesh, India. It's bordering China, and they've got about 50 million people. It's not a small country. I have no idea why we are the only 3 countries in the world. I do not get it. Mr. Kramer never was comfortable with feet at 12 inches, a yard at 3 feet, a yard at 36 inches, a mile at 5,280 feet. Does anybody else feel the same way that I do? If you do, trust me, you're in good company. 95% of the world uses metric. And the reason is it's all about powers of 10. Who can tell me what is 1/10 of a meter?
A centimeter.
Raise your hand, please. A centimeter is not correct.
One
William, go for it.
a millimeter.
A millimeter is 1/10 of a centimeter. Agreed. Seth.
Decimeter?
Decimeter, which is 10 centimeters, is 1/10 of a meter. Now, who can tell me what is 1/10 of a decimeter? Go.
1 centimeter.
Centimeter.
What's 1/10 of a centimeter?
Millimeter.
Millimeter.
And everyone, 1 millimeter equals 1,000 microns. I want to show you what that looks like for a second.
Wait,
So
is there?
a micron, guys, is over here. This is a micron. It is 1/millionth of a meter. So it's 10 to the -6 power. Now, how does that work? Well, you know that 10 to the 6th power is what? Say it out loud. 1, 2, 3, go.
Million.
1 million.
So 10 to the -6 is 1 divided by what?
1
million.
So negative exponents are not that difficult at all. In fact, they just mean small numbers. So scientists that want to talk about big numbers, they use positive exponents. Scientists that want to talk about small numbers, they use negative exponents. So when I talk about a 1 millimeter, everybody, my 1 millimeter, okay, is a millionth of a meter. If there's 1,000, I'm sorry, scratch that. 1 millimeter, 1,000 millimeters in every meter, okay? And there are 1,000,000 micrometers in every meter. Now, who can tell me a really cool pattern that you see on this page? Who's got something really interesting to share? Somebody who hasn't shared before. I'd like to hear from everybody. Brandon, I'd like to hear really from everybody possible here. David, what do you have?
The numbers, so like the 0.00 whatever, from the first one, yecto, a septillionth of a meter, is really, really long. And then as you go down the list and it gets closer to a meter, the numbers get shorter. And then as it goes away, down the list, they get longer.
That is awesome. That is awesome. Zarak, do you have anything to add to that? Any patterns that you see here? How about you? Okay. I thought maybe you'd want to share. Ethan, what about you?
It's a parabola.
Ah, now everybody look at this shape. This shape looks like a parabola, but it is actually part of something called a hyperbola. And the reason it's not a parabola, but it looks like it, Ethan, is a parabola looks like this, guys. A parabola is either up and down, up or down, where this one is sideways and is not a function. We're going to be doing algebra pretty soon in this group, and I'm really excited to teach you about functions and not functions. Now, who can tell? Oh, also, Lila, you have something to share. Go.
I was gonna say that in it from the middle point of a meter and the decimeter, it's all the numbers backwards.
Yes, it is. It really, oh, you know what? I want you guys to hold on to that comment. Listen to Lila's comment, and you're going to see something happen very soon. Adalia and Luca, last two comments, and then I'm going to show you something pretty amazing. Go for it.
Lila already said it.
Okay, cool. And Luca?
I forgot to put down my hand.
Okay, no worries. Now, are you guys ready for this? I have a special name for a Yata meter. Okay, I call it a Yoda meter. Okay, and it just happens to be the way that I remember 10 to the 24th power, which is in the Greek heptillion, in the Latin septillion. All right, and it's a Yada meter. I call it a Yoda meter because Yoda's pretty smart. Okay, so that's just my little thing. That is not a mathematical concept. Don't quote me on it as being part of math. Now, are you guys ready to take a journey with me? I'm going to take you outside of the universe this far, and I'm going to take you inside cell structure about this far. Would you guys like to travel with me through 10 to the 40th power meters?
No.
No, if you don't, then I get it. But if you do, fasten your seatbelts right now.
Quarantine adventures. We do it on a Zoom meeting.
Okay, are you guys ready?
Oh God.
This is a video that I saw back when I was 15 years old. In 1977, my teacher said, hey, Kramer, that's what they used to call me, these two guys from IBM. And I said, what's IBM? IBM is the greatest computer company in the world that existed before Microsoft and Google and all those. So IBM's been around forever. And these two guys created a video that has been in my mind forever. And I've probably watched it about every year since I'm 15. And I hope you do the same thing. By the way, I
The
want
sound's off.
you to listen to this. Now, the sound is going to be off because I am going to narrate it, okay? And I want you guys to be really quiet until the very end. But this is going to generate a million questions. Alex, question, go.
Is this the picnic one?
It is. It is. It is.
I remember
So,
this.
so let's take a journey together, guys. I was born in the state of Illinois. And this film deals with the relative size of things in the universe and the effect of adding on one more zero. So take a journey with me as we start with a picnic basket. And what you're going to see in just a second is the man will lay down, and we're going to start from 10 to the 0th power.
Oh, I think
10
I
to
saw
the
this.
0th power is
Why is this
exactly 1 meter. Now you guys can't talk at the same time that I'm narrating because we'll never get done. And I want to make sure we get through all of this. Okay? So this is a lazy afternoon in Chicago on the lakefront. We've got a, and by the way, everybody show me 1 meter, please. By the way, when you were 1 meter tall, your entire wingspan was exactly 1 meter. Now that you are taller than a meter, you have to bend your elbows to show the 100 centimeters or the 10 decimeters or the 1,000 millimeters or the million micrometers that make up a meter, okay? The width of your screen right now is 1 meter, 10 to the 0th power. Every 10 seconds, we're gonna look from 10 times further away, and our field of view will be 10 times wider. That square is 10 to the 1st power, or 10 meters. 10 meters is a little bit more than 30 feet. We are 30 feet above the picnic, the picnic blanket, okay? And our picture is gonna be centered on the picnic blanket at all times. You won't be able to see the picnic blanket in a few seconds. The next one is 10 to the 2nd power. 10 to the 2nd power is going to be 100 meters.
How did they film this?
Somebody has a question? Yeah, Olivia, go ahead.
How did they film this?
Well, it's interesting. They did use satellites, but you will see that there are some limitations, and this was created by the computers of IBM. And you'll understand why very shortly. So guys, no questions for just a few minutes while I show you the rest of the video. Here we go.
Okay.
Now, at 10 squared, you can see, and by the way, 10 squared is the distance that a human being can run in 10 seconds.
That's fast.
It's pretty fast. Now, 10 to the 3rd power, which is what we see right now. This is the distance a racing car can travel in 10 seconds. We see the great city of Chicago, Lakeshore Drive, and now we're gonna go out to, wait a minute, isn't 1,000 meters called something else? Who knows? Say it out loud, go.
Square kilometer.
A
It
kilometer.
is 1 kilometer. So at 1 kilometer, guys, look how small Chicago looks. And
Where is
here
it?
we go. 10 to the 4th power in meters is 10,000 meters. This is the distance that a supersonic plane can travel in 10 seconds. Now, you're going to be able to see the entire Great Lake at 10 to the 5th power. 100,000 meters. The distance that a hovering satellite covers in 10 seconds. You're going to see long parades of clouds, the day's weather in the Midwest. And at 10 to the 6th power, folks, soon you're going to see the planet Earth, guys. The sphere of the planet Earth at 10 to the 7th power. Pretty amazing. Now, at 10 to the 7th, you're going to start to see some amazing things. You're going to start to see now at 10 to the 8th, a line. Are you ready for it? Here it goes. Now, boom. That line that you just saw was a flash of light that took 1 second to go across, but it happened at the speed of light. It traveled 186,000 miles in that 1 second. And that is the same amount as the tilted orbit of the moon. And that's what you see right there, the orbit of the moon. At 10 to the 9th, you start to see the path of the Earth's orbit around the what, everybody? The sun. There it is. At 10 to the 10th power, that is a close-up of our orbit. And what do you think is going to happen at 10 to the 11th? We are going to start to see the orbits of the other planets. We're now going to see the orbits of Venus, Mars, and then Mercury.
Oh my gosh.
And do you
can't
see what
even
just
see it.
appeared?
Sun.
What?
The sun.
This
Sun.
is so cool.
The sun is our light.
That's how insignificant I am.
You are nothing but, you are anything but insignificant. We are small for sure, but we are not insignificant. Each one of us. Now, guys, I'm really excited to tell you about this. The next thing you're going to see, the very outer orbit, right about now, the outer orbit of Pluto crosses over at the outer orbit of Neptune. This is why Pluto was demoted to a dwarf planet about 10 years ago. But recently, in the last 5 years or so, Pluto has been renamed a planet because they've decided that the criteria for a planet is satisfied by Pluto. Do you think Pluto and Neptune could hit each other at some point?
Yes.
That chance is
Now,
tiny, though.
the chance is so small, and you're going to figure it out in a little bit. You're
The
going to
chance
figure it out.
is so small, but it'll happen eventually.
Yeah.
Yes.
Like it has to happen. If
Okay, Seth, it is going to be a race. It's going to be a race between the sun burning out
Mhm.
and the two planets colliding. I won't be around to figure it out, neither will you, but in about 6 billion years, we'll have that conversation. Alex, Jay?
Technically, it could be altitude, but I believe they may not ever crash due to the fact that if it has its own atmosphere, we may not be able to enter or maybe caught in orbit, or because how the moon was made also is about a Mars-sized rock that struck Earth in the molten phase, which is called the collision impact theory. So that could happen with Neptune, but Neptune is gas, technically. So I don't know, but there could be a collision, but because it is gas, if it's not dense enough, or if it doesn't have enough strength or gravity inside it, it could just potentially go through. It's a gas, but if it's strong enough, we could have a collision impact theory due to the fact that it's so soft, maybe.
Okay,
Could
all I
catch it in
know
its
is
orbit.
that, Alex, I want you to produce a video simulating the impact between Neptune and Pluto. I also want you to know that I don't know the ratio right now, but I'm actually thinking of maybe doing this in a future lesson, that the ratio, Neptune is colossal compared to Pluto.
Yes.
So Neptune is to Pluto as Jupiter is to Neptune. I mean, it's just an amazing size planet.
Pluto's tiny.
Yeah, so we'll see about that. Now, guys, I want to continue the video because we've got a lot to do. And by the way, remember, we're not just going out into outer space.
Yeah, we're gonna go.
We're going into inner space inside our cell structure. Are you ready?
Yes.
10 to the 14th power, folks. The solar system shrinks to one bright point. A fringe of 1,000,000 comets, too faint to see, completes the solar system. At 10 to the 14th power, our sun is barely visible. Now, at 10 to the 15th, something amazing happens. We hit 1 quadrillion meters. We hit 10 to the 15th power, which is 1 quadrillion. Notice that there are 4 constellations. Those constellations are actually seen in our southern hemisphere from our planet. And it is believed that at 10 to the 15th power, at 1 quadrillion meters, that's what we would see. Now, 10 to the 16th power is very special. And the reason is, it is a light year. Before we talked about the speed at which light travels. Light travels at 186,000 miles every second. Light can go around the Earth, let's see, 25, what about 7.5 times, guys? In 1 second. If light were to be shown into outer space and continue, let's do the math, guys. Ready? 186,000 times 60. That's a light minute. Times 60, a light hour. Times 24, come on, help me. A light day. Times 365.
Light year.
Light year.
And listen to this, guys. That is the number, and that number, you're not going to believe this. That number is close to 6 trillion miles. So we are 6 trillion miles away at 10 to the 16th, and I know that you don't see much. I know that you don't see much. Our perspective is now going to change, and even the stars are going to begin to converge at 10 light years. At 100 light years, we are going to pass the brightest star, guys. Guess what that is?
The North Star.
Andromeda.
That's Arcturus.
What?
Arcturus is the closest star to our sun, and we can't see it until we are 100 light years away. And there we are. We can also see some of the stars of the Dipper. Now, it's really, really interesting that as we continue taking these steps, we are going to begin to see the Great Flat Spiral.
Is it a nebula? No.
The great, guys, watch what happens. The Great Flat Spiral. Time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. And we are now
Milky Way.
100 million light years away. 100 million light years, and you're about to see the two little satellite
100,000.
galaxies of our own. We have two little satellite galaxies, guys. Check it out. And they're the clouds of Magellan. At 10 to the 22nd power, groups of galaxies bring a new level of structure to the scene. The glowing points at 10 to the 23rd power are no longer single stars, but whole galaxies of stars seen as one. And at 10 to the 24th, we pass a big vulgar cluster of galaxies among many others, 100 million light years away. As we approach the limit of our vision, we pause to start to go back into time. We're going back home. And I want you to see what happens. Guys, do you know that this is the norm? In space, there's nothing to see. We live in a very special place where there's a lot of activity. And I want you to watch what's going to happen as when we start to go back, we're going to speed up to a power of 10 reversed every 2 seconds.
Is that the
So I want you to picture this, guys. Everybody do a meter right now. Take your left hand and move it 90% of the way to the other. You should be 1 decimeter away. Now move 90%. You should be 1 centimeter away. Now move 90%. You should be 1 millimeter away. Now move, you really can't do it. That's what we're gonna do right now, guys. We're gonna reduce our distance by 90% compounded. Are you ready?
Well, then how did they?
Do we know more about outer space or smaller than atoms?
That is actually an amazing, that's not a good question. That is a brilliant question. I don't know the answer. I think we've been studying astronomy way longer than microscopy. So microscopy is the study of small things. Astronomy is the study of big things. We've studied it for longer, but I actually do think we know more about the atomic structure.
Yeah, there's so much.
So Seth, you can't hold me to that because I don't know, but that's my
There's so
conjecture.
much stuff in other galaxies that we don't know about, though.
That is true. Alex, what were you going to share?
I believe that were all those the area of galaxies was that Virgo supercluster.
Yeah, I couldn't really hear you very well. The audio is just not crisp.
Was that area of galaxies that we just saw the Virgo supercluster?
Ah, I do not know. I actually do not know, but I would love to do some research on that. Now, I want you guys to watch what happens. I want you to go watch what happens as you are going to see alternating great activity and no activity. Here's great activity right here. And then pretty soon, no activity. No activity. And now great activity is going to start up in a few seconds. Look at the great activity, guys, of our solar system. Unbelievable. Look at the great activity of planet Earth. And here we are, 10 to the 9th, 8th, 7th, 6th, 5th, 4th, 3rd, 2nd, 1, and 10 to the 0.
Negative.
We are now back.
Yeah, we're going into the cells, I remember.
Now, who would like to take a journey inside his hand?
Not really.
We're going to go to 16 powers of 10.
Oh.
Are you ready? And by the way, if anybody sees any comparisons to outer space, let me know. Here we go. So we're now going to go to 10 to the negative 1 power. Who can tell me how many centimeters that is? Raise your hand, please. 10 to the negative 1 power meters. Dahlia, go.
10 centimeters.
Let's see. Is she right? Perfection. Also known as 1 decimeter. Yes, guys? And now you are going to start to see 10 to the negative 2, which is 1/100th of a meter, 1 centimeter, as we approach the surface of the hand. Here we go. There it is.
Wow.
Oh,
And boom, 10 to the second. Now we're getting really, really close. You know what's going to happen next. 1 what?
Oh, 1
Micron.
1 millimeter or 1,000 microns or 1,000 microns. There we are, 1 millimeter. We are 1 millimeter away. We're entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Now, at 100 microns, 10 to the negative 4, skin layers vanish in turn, and outer layers of cells will be shown. Now, this is my favorite picture. At 10 to the negative 5th, which is 10 microns, we enter the white cell. Guys, we are going to start to see the nucleus of this cell appear.
Oh, no.
At 1 micron, 10 to the 6th power.
That thing
I'm
destroys
sorry,
Corona.
negative 6.
Oh, no.
This is the nucleus within which holds the reality of us. Everybody point to themselves right now. This picture, guys, is your DNA.
Yeah.
This is your DNA. At 10 to the negative 7th power, which is 1,000 angstroms, you can see the double helix itself. It's like a twisted ladder whose runs of pairs, bases spelled out 4 letters. Those 4 letters are our genes. It makes up you and me. It's pretty amazing stuff. And Seth, we know a lot now about genealogy. Really cool stuff. This is the genetic message. Now, at 10 to the 8th, at the atomic scale, the interplay of 4 electrons in motion becomes more visible. At 10 to the negative 9th, we focus on one group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. Any connections here, folks?
It's nothing.
Zarak, wait, Zarak, what do you see?
It looks like a galaxy.
Yeah, Zarak, that's exactly what it is. There are galaxies of stars inside each and every cell. Luca?
That's creepy.
Luca, you'll have to speak up. It was jarbled.
That's kind of weird.
You think so?
Yeah.
Yeah, it is pretty amazing. Would you guys like to go a little further?
Yeah.
It's a little crazy. Here we go. Put on your seatbelts.
No.
You're gonna need it.
Oh.
Now, guys, at 10 to the negative 10th, we are now, whoops, hold on. At 10 to the negative 10th, the last one before that, we were in the outer electrons of the cell. We are now going to come upon 10 to the 11th at 1/10 of an angstrom, okay? This is the center of the cell, and we're about to go to 10 to the negative 12.
Oh no.
This is the nucleus, guys. Wait, what does that look like?
A dot.
The galaxy.
It looks like the sun. Doesn't that look like our solar system?
It would be a
Watch
good
what
ending to
happens.
the video if they like zoomed in and then went into the sun again.
And now look at it, guys. It's
Oh
amazing.
yeah, it turned into the sun.
It's amazing. This carbon nucleus is made up of 6 protons and 6 neutrons. Okay?
It would
Go
make a
for it.
cool looping thing if they did all of that and then that was the sun and they just like did it over and over again, like zooming out.
Do you know, guys, do you know that when I saw this video for the first time, I thought of a book that I read called Horton Hears a Who, okay? So Horton Hears a Who is a Dr. Seuss book that talks about a little particle of dust that is actually an entire universe. And I actually thought of and if I were you guys, go into your library right now, ask your parents to read to you Horton Hears a Who. You're gonna laugh.
already heard the
Oh, that's such a
musical.
baby
I
book.
used to
It is
read that
not
book so
a baby
much.
book. Okay, are you guys ready? Here we
So-
go.
I've
There are
already heard the
protons
musical.
and neutrons in every nucleus. Electrons in every atom. Atoms bonded to every molecule out of the farthest galaxy. And now, guys, we are going to look at a single proton. That's it. That is a single proton filling our space. And guess what? I got nothing more. There is no more knowledge that humans have
Sight.
right now except for what we think might be true. Notice what happens at 10 to the 15th. We enter the world of quarks. Quarks I don't know what quarks are, but quarks make up protons. What makes up quarks?
Whoa, they're so movie.
Entire
They
universe.
have
It's
Guys,
worms.
I leave you with that question. Could we go further? If we understood what makes up quarks, we actually could go further. Now, as I told you, I gave you the link to this video. Let me see if I can find it real quickly for you. There it is. There's the link. I also gave you a complete narration of the slide so you can really study it. This video is going to spark 1,000 questions. If the average one of you will probably come up with at least 10 questions, I still have questions about this. So for instance, I'm really interested in some of the questions that Alex asked, some of the comments, I think Will and Seth and Zarak, David, Adalia, and also I think that Luca, really amazing stuff. Ethan, Alex. So I want you guys to have some fun with this. Now, for the next few minutes, I just want to take you through a little exercise. I gave you 10 to the 0th, which is 1, times 33. And I want you to see these beautiful patterns. Do you see the patterns of zeros?
Yeah.
Now, this isn't really very difficult stuff, but the patterns of zeros are quite beautiful. Now,
I
here,
need to use the bathroom. Is that fine?
you do not have to ask questions. You just go and then you come back, okay? And guys, this one here is also relatively simple, but we're going the opposite direction. 10 to the 0th is 1, 10 to the negative 1 is a 10th, 10 to the negative 2 is 100th, and all we have to do is move the decimal over. So let's try one, guys. Let's try one. Let's do 4 times 9 times 10 to the 0. On 3. 1, 2, 3, go.
That is 36.
Now, on 3, 10 to the negative 1 times 36. Go.
3.6.
Keep
This is
going.
literally the same exact thing we're doing.
36.
0.36.
Keep going.
Point oh
36.
36.
0, 3, 6.
And?
36.
And guys, it's so beautiful to think of small numbers. And small numbers are everywhere. That's microscopy. Now, I want you to look at what I've given you, but I've also focused on this page. I really like this one because it really tells you, it says, okay, if you've got 91407 and you start with a decimal right there, and you say, okay, I'm gonna multiply that by 10 to the negative 3. Watch what I do, guys. I take this decimal and I move it 1, 2, 3. So that ends up being 0.00911407. How about this one right here? Go. Come on, point.
0.0054.
You see how we went 3 decimals? How about this one right here?
0.07927.
And it really, really works. What about this one here? Let's see, 6.23 times 10 to the negative 24th power.
Point
Zero, zero, zero.
3 zeros.
13,
And then
14,
6, 2, 3.
16, 17, 18, 19, 20, 21, 22,
0,
22, 23.
0, 0, 0,
6, 2, 3.
0,
Now,
point
I
23.
think,
Or 0.623.
guys, I think that I wrote down 23 zeros in front of the 6.
Yep, that's what I counted.
And if I did, now I tried to count it with clusters of what?
3.
3. But
So
isn't it
I-
supposed to be?
You need one more zero.
I think you need one
It
less.
was 6.23.
No, it's right.
Split it
It's
over,
23.
and that counts as one.
Yeah, don't you need one less?
No.
Guys, do me a favor. Go back here whenever you have a question and say, okay, when I had 10 to the negative 2 power, I had 1 0 between the decimal and the 6. 10 to the negative 3, I had 2. So 10 to the negative 24, I have how many zeros?
23.
23 zeros. Luca, question.
Is there any limit to how small things can go?
Yes, there are. And it is only a function, Luca, of our understanding. So for instance, Luca, if we are really smart, let's see where we can go with this. Here we go. I am only smart enough to understand 10 to the negative 24th. Lengths that are smaller than that do not make physical sense. Now that's my own comment. It might make sense to a theoretical physicist, somebody like Tyson, okay, who is a physicist and one of my favorites. I also, Luca, do not understand anything greater than 10 to the 24th power, 1 iota meter. Okay?
I don't understand the negative H meter. I mean the upside down H meter.
Oh, yeah. That guy is just a Greek symbol for micro, and I think it maybe even is called like an umla. I don't quote me on that because I'm not a Greek Latin scholar. In fact, I'm just barely getting through English. And by the way, who's got that cool background with like a t-shirt with a spiral on it? I can't really tell who it is, but it's really, really cool. So what I want you guys to do this week is I want you guys to explore every one of these opportunities. Now, what we're going to do right now is let us go in to 300%. And we're going to go from a iota meter, and we're going to count negative 24 all the way to 0 by threes. Ready, go. Negative 24. Go.
Negative
21. Go.
Negative 18.
Go.
Negative
15. Go.
Negative 12.
Negative 12. Go.
Negative
9.
Keep going.
Negative 6. Negative 3.
But don't
Negative
ever say
0.
negative 0, 2, 4, 6, 8. Who do we appreciate? Yoda. Go Yoda. And I want you guys to say goodbye to your friends. Say goodbye to Yoda.
Bye.
And I hope that you are inspired the same way I was inspired many, many years ago. Take care, everybody. You were awesome. You were awesome. Thank you so much, guys. Bye, Reagan. Bye, Ethan.
Bye.